Hi, now we are going to do final exam question 3. This is the main question, and it was in the homework. So I believe all of you have done well. So we have basically, there are many explanations, but just a regression and some nice assumptions. And right, like we have measurement error. So that's a typical problem. Okay, so let me start my solution. We have y equals alpha 0 plus beta 0, li plus gamma 0, ki plus epsilon I. This is true model, but as you know, k is not observed. That is the problem. So instead of k, we have h, which is ki plus ui, right? So these two are the most fundamental equations of the model, right? So all we have are coming from these two true models, true equations. Now let's think about part A. When you regress y, so we observe y, L, and H. Okay, so I will define x as a vector in constant term, labor, and a capital measure. So if you like OLS will estimate, so OLS, say I will denote it as theta hat, theta and hat will be estimating like excuse me, how do I erase it? Erase. You are going to estimate the coefficients in this way: xi transpose inverse xi yi. Okay, so we are going to estimate three vectors. Remember, it's 3 by 1. So this is 3 by 3, and this is 3 by 1 because y is 1 by 1. Okay, then we want you to show that it will converge in probability to expectation of xi transpose inverse expectation xi yi. We wanted to show that it's difference from the desired parameters, right? I will denote it as, say, theta 0. Theta 0, what we want is the coefficients of the true model, but the difference is, remember, k is replaced with h. So we are regressing h in the place of k. Then what will happen? Let's try this at the page. And then to do that, as I said, the p limit of theta hat n is expectation x prime inverse expectation x y. Okay, we will rewrite the y as using the true model. Y equals theta like wi transpose theta 0 plus epsilon, where w is the true capital. Remember, x is constant labor and a measure of capital. So the difference is w is the true but not infeasible, but this is observed, right? Observed with error. In this case, what we can do here is we may rewrite y, which is w transpose theta 0 plus epsilon, as actually alpha 0 plus beta 0 li plus gamma 0 ki plus epsilon. I will I try to replace k with h by this way, okay? So that is alpha 0 plus beta 0 li plus gamma hi, and then the error term now becomes epsilon minus gamma 0 ui, okay? So that is xi transpose theta 0 plus epsilon I minus gamma 0 ui, right? I will actually use this in here, okay? Another page. Then, again, we are looking at this, and we just saw that xi transpose theta 0 plus epsilon minus gamma 0 ui. And then, as you see, this will be cancelled out with this. So you start from theta 0 plus expectation x prime inverse, and still remains xi times epsilon I minus gamma 0 ui. Okay, so remember, now we will think about, because we already have theta 0 here, this much is the bias if it is not 0, right? That is the bias. Let's think about first this. This is x is a vector, so we can rewrite this as hi epsilon I. Okay. So x, like if we think about x and epsilon first, we assumed epsilon has mean 0. This is 0. Also, we assume that epsilon is uncorrelated with labor. That's fine. And the final term is ki plus epsilon. Sorry about that. So what I wanted to say here is, you can rewrite this as ki plus ui times epsilon expectation. That is also 0, right? Because we assumed epsilon is uncorrelated with all the inputs, and also the measurement error has nothing to do with the total factor productivity, epsilon. So it is 0. So this term does not matter. It is not a problem. The problem is coming from expectation xu. That is also expectation of u, expectation of liui, and hiui. The first two terms are 0. U is just a measurement error, which has mean 0, and measurement error has nothing to do with, measurement error for capital has nothing to do with labor input. The problem is the last one. Again, k plus u times u is u squared, like expectation. If you take the expectation, k and u are uncorrelated. The measurement error is uncorrelated with the true capital, but u itself cannot be cancelled out. So it is not 0, and I will denote this as 0, 0 sigma u squared. Okay? Okay, then we just found that this is the problem. Okay? And then in the next page, so what we learned is the bias, the misspecification bias, can be written as xi transpose inverse expectation xi times epsilon does not matter, but what matters is this, right? And that can be written as expectation xi transpose inverse times minus gamma 0 times expectation xi ui. Okay, that is, say, minus gamma 0 is scalar. Check the dimension. X prime is 3 by 3 dimension, gamma is 1 by 1 dimension, and it is 3 by 1 dimension. Okay, so gamma 0 can go out of go in front, and we write it here times, and we assumed it is this. X and U expectation takes this form. Then you can calculate the bias, misspecification bias, if you can calculate this part, right? Multiplication to the last term is not that hard, but the problem is it is not easy. It looks like x prime will take this form. 1 expectation Li, expectation Hi, expectation Li, expectation Hi, expectation L squared, expectation H squared, expectation LH, expectation LH. So you have to invert it. 0, 0, U. This, if this is possible, that would be great. But of course, this is not a clever way to do that. So then, what you should have done was demeaning. Or that means just simply erase, remove the intercept. We did this in chapter 1. We did this in homework 1. That means we are going to redefine, say, yi tilde as a new variable, which is yi minus y bar, where y bar is the sample average. Similarly, like li tilde is li minus l bar, and everything like h, like ki tilde is ki minus k bar, and hi tilde is hi minus h bar, right? All of these transformation then all have mean 0. So then, as you did in homework 1, we do not need the intercept. We only use 2 parameters. Okay. Okay. So, and also in this case, of course, from this you can write it as. So using this relationship and these two relationship, you can derive the same thing we did earlier. So the bias will be expectation of xi tilde, which is demeaned variables, xi tilde transpose inverse, and expectation xi tilde and y tilde. So just replace everything with tilde and then repeat pretty much the same algebra, and you are going to get this minus theta 0 will be will look like expectation xi tilde times expectation xi tilde times minus gamma 0 ui, right? This is the same thing, right? Then you get the bias as minus gamma 0, which is the same, and expectation x tilde I like prime inverse times 0, 0 sigma squared u. Okay, and then it only remains to calculate the inverse of this, which is 2 by 2 matrix. Expectation xi tilde transpose is expectation li tilde squared, expectation li tilde k h I tilde k, sorry about that, K tilde, expectation Li tilde, Ki tilde, expectation Ki tilde squared. Okay, and you know how to calculate this inverse. By the way, a simple tip here is actually this is variance, because already you are calculating this, right? In the end, if you have infinite observations, L bar will be expectation of Li, so it is just the same thing. And similarly, K tilde squared is variance of K, and expectation L tilde K tilde will be covariance between L and K. So use them, and then the bias will and then this matrix can be written as, I would write it as sigma L squared and sigma LK, sigma LK, sigma K squared, something like this. And it is inverse. Its inverse takes the form of sigma L squared sigma K squared minus sigma LK squared in the denominator, and then minus sigma no minus, excuse me, K squared sigma L squared minus sigma LK minus sigma LK. Okay, and this is the inverse part. And then when you my bad, so here it is two-dimensional. Now we don't have the first part because we don't have intercept. It is 0 and sigma u. So you have to calculate minus gamma 0 over this guy here and this matrix here times 0 times sigma u squared. Then you calculate, and the answer is same as homework 1, homework 2. So it is just purely algebra. So I'm not going to say more about that. That was part A. Part A, we derived the bias. I have to derive misspecific bias. Then what is the direction of the bias for gamma 0? Let's go back and do the algebra. Maybe we need to do it. So this is always positive, so it does not matter. And if you calculate that, something in the denominator and minus gamma 0 and multiply this, it will become minus u squared, sigma u squared times sigma LK, and plus sigma L squared, sigma u squared. So the bias, second term is the bias for, no, how do I redo it? Undo it. Okay. So this is bias for gamma, and this is bias in beta. Okay, so bias in gamma is, in the end, minus gamma 0 over something times L, sigma L squared, sigma U squared. Okay, and then of course it is positive, it is positive, it is positive. And gamma 0. Gamma 0, is it positive or negative? Of course it is positive, because this is the productivity of capital, right? When you input more capital, you will produce more. So as long as capital is a normal input, then gamma should be positive. So you can guess it from economic theory. Then as a whole, the bias will be negative. That means your theta hat n will underestimate approximately p limit of theta hat will be smaller than, gamma hat, gamma will be smaller than the true gamma 0. So I'm not sure if I told you before, we call this attenuation bias. So the idea is, it is bias toward 0. So in our case, we assume gamma 0 is positive. So gamma hat will underestimate Okay, but now let's think about gamma is negative. If gamma was negative, the bias will be positive. So what that means is if gamma was negative, then gamma hat will be overestimating, right? So that means if you think about 0 here, if if gamma 0 was here, then your estimator will be underestimating like this. But if your truth was negative, then your estimator will be here, overestimating. Okay, so in any case, it is biased toward 0. Okay, that's a typical patterns in phenomena when you have errors in variable. This makes sense because when there are measurement error in a variable, it like the measurement error has basically no effect on the outcome, but it looks like x increases or decreases. So it dilutes the it makes the effect of x weaker because actually x did not change, but because of the measurement error, x like may look greater or smaller, but y does not change. So the output does not change. So this causes like weaker relationship. And then by weaker, I mean biased toward 0. It may look like the actual relationship is weaker than the truth. That is what I wanted to say, wanted to add. I think I mentioned it in, I'm not sure, on homework 2. Should have mentioned it in homework 2. And the next one, let's see, we have, we have now 3 models. We have the original production function, but now, so suppose that, suppose all have mean 0, right? So demeaning is kind of the starting point. Everything is mean 0, and I'm not going to use tilde. We just use this true production function and the relationship of one measure of capital and relationship for another measure of the capital, right? Now we have 3 underlying structural equations. This is what we are working with. And then we wanted to, and you know the answer. I want to use, so k is not observed, not available. So we are going to use y minus beta 0 li minus gamma 0 hi. In the place of k, we are going to use h, and then we will use g as another variable, like as the instrumental variable. We want to show this, right? Right? Of course, like I will prove it later. By the way, it is not sufficient for identification, right? So you have to also discuss this moment condition. Second moment condition is actually obvious. Like labor input was exogenous, and I can prove it later. So it is pretty straightforward. And by the way, what is wrong, useless, is this. So we do not need this one because if you expand, so this means just the error term has mean 0. This is useless in our case because we already assumed everything has mean 0. Like rewrite this as yi minus beta 0 expectation li minus gamma 0 expectation hi equals 0. So the unknowns are beta 0 and gamma 0. But the problem is the unknown's coefficient is already 0. So basically, this is not a function of unknowns, right? Unknown disappears. It's irrelevant. It is always true, so it does not provide any information. So the exogenous conditions we need for identification are these two. And how do we prove that? First, we already proved that in the previous part, we showed that it is this one, okay? Right, this UI is the measurement error in H. Right, we have to consider this one, and I will plug this into this and this. Then another page. It is easy. Let's see gi and epsilon I minus gamma ui can be written as it is 0 because gi is ki plus wi, and expectation of ki epsilon I is 0 by assumption in the question, and expectation of ki ui is 0, which is also by assumption. Measurement error is not correlated with the true capital, and this is total factor productivity does not depend on input, and then also measurement error in G has nothing to do with the total factor productivity, and measurement in G also uncorrelated with measurement error in H. So from these four assumptions that I made in the question, we can show this. So it is 0. Similarly, like Li epsilon I minus gamma ui, it is easier to prove because it only need two assumptions. Okay, from this we get this, and then we can show the second part. Let's see if there is any other thing I had to explain. So I just proved that find the moment conditions you can use to estimate equation 1. I can use those two moment conditions to identify excuse me. So these two moment conditions for beta and gamma, because intercept is gone, right? So it is totally fine. And then if intercept is needed, you can recover it from the mean relationship, like expectation of yi equals alpha 0 plus beta 0 times expectation of li plus gamma 0 times expectation of hi plus error. Error has mean 0. So like those two moment conditions identify beta and gamma. So these are identified, and those expectations are of course identified. Then alpha is identified in like from this regression, like from this relationship. Alpha 0 is expectation y minus identified beta times expectation of L minus identified gamma times expectation of H. So in this way, you can prove the things, or I mean, let me be more clear. Here, you may use expectation of k, but expectation of k equals expectation of h, because the measurement error does not change. Like my k and h look too similar. Sorry about that. So you can identify all the parameters, and if you did not use this demeaning condition, then you will automatically identify 3 parameters at the same time, alpha, beta, gamma at the same time. But of course, at that time, you have to use this as the third moment condition. Oh, it's gone. Yes. So it will be the third moment condition you need to identify the instrument 2. Okay, I will continue in the next video. Thanks for watching.